Hey guys, so I'm here to record some videos of me talking more about limits at infinity. And first we're going to talk about polynomials over polynomials, and then we'll talk about kind of some other weird cases. So in terms of polynomial over polynomial, we're going to look at a couple different results. So if you have some function which is equal to a polynomial on top divided by another polynomial on bottom, there are going to be a couple different cases and rules we're going to develop, and I'm going to teach you a shortcut for where all those rules come from for how you take the limit as x goes to infinity of that function. Okay, so here's the key trick. And the trick is you only need to look at the leading terms. The leading terms, remember, the ones with the largest exponent. So you only need to look at the limit of the leading terms. And I'm going to fill out this little table on the side as we go, so make sure you save some room for that in your notes or whatever. Okay. So, and the reason for this is that as x goes towards infinity, the difference between an x to the 4 versus an x cubed is huge. An x to the 4th is way, way, way bigger. An x squared is way, way, way bigger than an x. And in the sense that they're inconsequential, right? A billion squared is so much bigger than a billion that you don't even care about that. And that just gets bigger as the x values get bigger. So what I mean by that is if you take a limit as x goes to infinity, let's say of 3x cubed plus 5x minus 7, and I divide by 4x to the 5th plus 7x squared plus 3x. Well, here's what I mean by that. Basically, all you have to do is just look at the limit of leading terms. So we take a look at the power, or the terms of the highest power. So look at the limit of these. So I'm just going to say, let's take a limit as x goes to infinity of 3x cubed over 4x to the 5th. And this only works as you're going to infinity, which is important. So let's simplify this a little bit. Simplify this so this becomes a limit x goes to infinity of 3 over 4x squared. We can cancel out an x cubed. So anyway, this goes to 3 over 4 times infinity. And of course, any number over infinity is equal to 0. So remember, what that means is that if you have a horizontal asymptote, you have a horizontal asymptote at y equals 0. Let's try one other case. So if you just take a limit x goes to infinity of, say, 2x over 7 minus 5x squared, again, you just say, I'm going to look at the leading terms on top and on bottom. We'll keep that minus sign. So we just say, let's take the limit x goes to infinity of 2x over negative 5x squared. So that just goes to 2 over negative 5x, which again is 2 over negative infinity, which is 0. Okay, so that makes sense. So let's go ahead and graph this and make sure, because that would mean we have a horizontal asymptote at 0. So we have 2x over 7 minus 5x squared. Okay, so we're going to graph this. So we have 2x divided by parentheses 7 minus 5x squared. Okay, and as we graph this, we see as we take a limit as we go towards infinity, it does in fact go to 0, right? We see there's this height of 0 it's going towards on the right and on the left, actually. So that's good. The graph matches our answer. We have that horizontal asymptote at 0 that we expect. Okay, so that's pretty good. And that's actually, both of these examples are going to show us our first rule, right? Both of these have the highest power on the bottom, like x to the 5th over instead of an x cubed, x squared instead of an x. So if you have the bigger power on bottom, this is actually always going to be the case that this limit turns out to be 0. Okay, and that's a general rule and a shortcut you can use. Now, all the cool kids are asking, what if you have the bigger power on top? Well, let's take a look. So what if you take a limit x goes to infinity of x to the 5th plus 2 over 3x squared? Again, let's look at our leading terms. So we have that and we have that. So we're going to take a limit x goes to infinity of x to the 5th over a 3x squared. So we can cancel out an x squared on top and bottom, right? If I do x to the 5th over x squared, I subtract those, I get x to the 5 minus 2 is 3. So I do a limit x goes to infinity of x cubed over 3, which is infinity over 3, which is infinity. Okay, and this actually makes sense because if you take a look at this graph, it does actually kind of go up towards infinity off to the right side. Okay, what if we try another one? Let's take the limit as x goes to negative infinity of 3x cubed plus 1 over 5x squared minus 6x. Okay, something a little different is going to happen, but I think you'll be all right. So again, let's look at those leading terms. So this is the same as, it's a 3 on top, just a really bad one. The limit as x goes to negative infinity of 3x cubed over 5x squared. So we can cancel out 2 of the x's. That's actually just a limit of 3/5 times x. So as we go to negative infinity there, that's 3/5 times negative infinity, which of course is negative infinity. So on the graph, that just means you go down to the left side. Okay, so that's actually our next part of the rule, that if we have the bigger power on top, the limit is going to be plus or minus infinity. You're just going to have to do some analysis with the leading terms to figure out which one that's going to be. Okay, great. The next thing we're going to look at that all you guys are asking, what if you have the same power on top and bottom? So for example, what if I asked you to find the horizontal asymptote of this function? Now, by the way, whenever someone asks you to find a horizontal asymptote, you should really just think of that as a limit as you go to infinity. So this over, say, x plus 3 squared. Now, one thing I am going to do here is multiply out the bottom a little bit. So that goes to x squared plus 6x plus 9. All right, so when it says find the horizontal asymptote, again, you should read that and turn it into calculus as, oh, they just want me to take a limit as we go to infinity. So I'll look at the leading term. So that's of negative 2x squared over x squared. Those cancel. So we just get negative 2. Huh, interesting. So we have a horizontal asymptote at y equals negative 2. All right, so what that actually means is you're approaching this value of negative 2. Who knows what's going on, but somewhere as you go off towards infinity, you're going down towards that negative 2 and kind of approaching the horizontal line there. So where did the negative 2 come from? Well, we had a negative 2x squared and a 1x squared. It turns out it's just the ratio of those leading terms. So if I ask for, say, a limit as x goes to infinity of, 3x cubed plus 7 over 6x cubed minus 2x squared, you just look and say, okay, we have the same power on top and bottom. The leading terms there are 3 and 6. The coefficients are 3 and 6, so that's my limit. So if we have, going back to our table here, if we have the same power on top and bottom, that limit turns out to be the ratio of those leading coefficients. So what are the coefficients of those highest power terms on top and bottom? Okay, so that's what's going on there. Let's go on and talk about a couple other things. One is that this still works if you have a square root. You're just going to include that as part of the leading term. Okay, so here's what I mean by that. If I ask you to take a limit as x goes to infinity, let's say of 16x to the 4 plus 2 inside a square root, all divided by 3x squared minus 5. We're still going to consider the leading terms, but we're just going to count the square root as part of it. So I'm going to take that guy right there, and I'm going to take that guy right there. So I'm going to say, let's take the limit as x goes to infinity of square root 16x to the 4 over 3x squared. Guys, I know this looks like pretty sketchy to just kind of take the square root of something else and separate it, because normally you can't do that. But when you're considering leading terms, you can. So you might notice we can simplify the square root. So this just becomes a 4x squared over 3x squared. And then you're like, oh, the x squareds cancel. It's just 4/3. Or maybe you had a bigger power on top or on bottom, and you can figure it out from there. But that's the general idea. You can still just take the square root, consider that as leading terms. Okay, I want to talk about just some other limits as you go to infinity. Say, for instance, you take the limit as x goes to infinity of e to the x. Well, that's e to the infinity. Remember, e is roughly around 2.7. We're going to deal with it a lot later. But if you do e times e times e and just keep multiplying that in perpetuity, that does in fact go to infinity. Okay. If you take the limit as x goes to negative infinity of e to the x, of course that goes to e to the negative infinity, and we write it as a positive exponent on the bottom, so that's 1 over infinity, which is 0. Those limits will come up every so often. If you take the limit as x goes to infinity of the natural log of x, well, what that's saying is that's saying e to what power is equal to, well, if you plug in, you get ln infinity, which is saying e to what power is equal to infinity. That's what ln infinity means. Well, e to the infinite power is infinity, so that is still infinity. Some other common ones, what if you take the limit x goes to infinity of sine of x? Well, what happens there? Geez. So I mean, like, sine of infinity doesn't make sense. It's not like a point on the unit circle, obviously. If you think about the sine graph, it goes like that. It just keeps going up and down and up and down and up and down. Does that approach a single value? Like, is there a number it reaches or a horizontal asymptote? No, right? So this limit does not exist because there's no, like, one value that it's settling on right there. Okay, and then the last one I wanted to take a look at just kind of for fun, and this is just kind of a cute one. What if you took the limit as x goes to infinity of 5? Well, is there any x to plug in? No, right? This limit is just 5. So it's saying, like, if you have the line y equals 5, if you look at what happens as you go to infinity on 5, you still have a height of 5. Okay. So anyway, I hope this video was useful and helps you build some intuition about these limits and kind of get used to working with infinity. I hope you guys have fun with this, and I'll see you in class.